Hello student. Again welcome back. Again we would like to discuss analysis of tension member, single angle bolted connections. So what are the steps? The first step is given data. Second step, the strand governed by yielding of cross section that is available in IS 800 page number 32 clause 6.2. Next step, strand governed by the rupture of critical section. It is available on page number 33 clause 6.3.3. Then strand governed by the block shear. Again page number 33 clause 6.4.1. Okay. So look at one more example that was asked in December 2013 and October 2016 in GTU examination. What is that? A tension member comprised of angle ISA 80 by 80 by 8 mm is connected by 7 numbers of 16 mm dia bolt to a 10 mm thick gusset plate. Calculate the tensile load capacity of the member. Take edge distance and pitch distance 50 mm for the bolt. So here what happened? Edge distance and pitch distance both are given. So it does not require to calculate. Okay. So first look at the given data. Diameter of a bolt is given 16. So that's why diameter of a hole 16 plus 2 18 mm. Yield stress and ultimate stress is not given. So we can assume Fy 250 and Fu 410 Newton per mm square. Now the first gauge distance, again 60% of connected leg. So it is 60% of 80 length of the connected leg. So it is comes to the 48. So we considered gauge distance G equal to, here is I am taking 45 mm. So G equal to 45 mm, this distance 45, or you can say that this distance here to here. Okay. Now the first step, what is that? Strand governed by the yielding of cross section. Page number 32 clause 6.2. So look at this page number 32. This one. TDG equal to AG Fy divided by gamma m0. So same equation is here. TDG equal to AG Fy gamma m0. Where the AG comes? AG comes from the steel table. ISA 80 by 8 mm. Okay, so we get the answer of a TDG. So that is comes to 277.50 kilo Newton. Now second step, from where? The second step from page number 33 6.3.3. So page number 33 6.3.3 for the single angle. What is that? Rupture strength. So where is? Yes, here it is. The strand covered by the rupture of the critical section. Okay. So same equation. TDN equal to 0.9 ANC into Fu divided by gamma m1 plus beta A Ag0 Fy divided by gamma m0. So for beta, this is the equation we already discussed. What is the W? Outstanding leg. So this is outstanding leg, W equal to 80 mm. BS, shear leg width. So using this figure, connected leg, outstanding leg. So outstanding leg plus this gauge distance, you can say that WL. So it is 80 plus 45. So what is that? This is your 45 mm. This 45. Okay, which one? This 45. Fine. So here BS equal to 80 plus 45 minus what is this? Thickness of angle. So you get this 117 mm. That is your shear leg width BS. Fine. Now we'll see. Center to center distance between the outermost bolt in the direction of the load. So first bolt to the last bolt. So this distance here to here. So it is 50. How many 50s? 1, 2, 3, 4, 5, 6 50s plus 30. LC. First of all LC. So LC is the distance between this center to this center. So it is a 6 times 50. 1, 2, 3, 4, 5 and 6. So 6 into 50. That is your LC. Okay, now put the value of it is W, BS and LC in this equation with the FU and FY. You get the beta. Beta should be more than 0.7 and should be less than this equation. What is this equation? That is given in your IS code. Beta should be less than FU gamma M0 divided by FY gamma M1. So what is gamma M0? Gamma M0 is nothing but 1.10 and gamma M1 is nothing but 1.25. So beta is in between these two. That is okay. What is the next step? You must be calculate ANC. Why ANC is required? So getting this TDN, ANC is also required. So ANC as well as AG0. Okay. Now ANC. So it's the net area of the connected leg. How it is calculated? Look at this. This is your 80 connected leg minus 18. This dia of a hole minus half of the thickness. Half of the thickness. So 80 minus half of the thickness minus 18 into the thickness. So that is a net area of the connected leg. Similarly, gross area, because it is outstanding leg without hole. So 80 minus this 8 by 2. Why? Because it is calculated from this. So total 80 minus this 8 by 2. Up to here it is 80. This distance is 8 by 2. What is 8? Thickness of angle. So here to here. So this is the distance into thickness. So that is the gross area. So after getting ANC, AG0 and beta, you put it over here for the TDN. You get the answer of a TDN. What is the TDN? Strength governed by the rupture of critical section. So you get the answer TDN equal to 305.55. The second answer. Okay, fine. Now the last step, strength governed by the block shear. So this is the equation where it is available again on a page number 33. Design strength due to the block shear. This is for the bolted connections. These are the two equations, minimum of these two. Okay, so in these equations what required? AVG is required, AVN is required, ATN is required and ATG is required. These are all the areas. Okay, fine. So how it is AVG? What is AVG? AVG is nothing but minimum gross area in shear along the bolt line parallel to the external force. Okay, so from where it is calculated? From the center of a first hole. So here, okay, fine. So what is 6 into 50? So how many 50s? 1, 2, 3, 4, 5 and 6. So 6 into 50, agree? Plus 30. What is this 30? 30 is nothing but your edge distance. So here to here, this length into the thickness, that is nothing but 8. So you get the first answer AVG. Okay, fine. What is AVN? That is a net area in a shear. Fine. So how it is calculated net area? So you must be deduct the area of a hole. Okay, so 6 is a complete hole and half is another hole. So total hole, bolt is 6.5. 6 complete, 1, 2, 3, 4, 5 and 6 plus 0.5, so 6.5. What is the dia of a hole? 18. So this must be deducted from where? From the total length. What is the total length? 6 into 50 plus 30. So here to here minus this hole, half, 1, 2, 3, 4, 5 and 6.5. Okay, fine. So this is the way you can calculate AVN. Okay, ATG. So ATG is related to the connected leg. So remaining distance is a 35. So 35 into thickness. And ATN net. So again you remove this half area. So it is this total 35 minus this portion. Half the dia into thickness. So you are calculating all the areas. After getting all the area, put in the equations TDB1 and TD2 along with F5 and FU, gamma M0 and gamma M1, gamma M0 and gamma M1. What is the gamma M0? Partial safety factor 1.10 and gamma M1 1.25. So minimum of these two, smaller of these two is nothing but the TDB. Okay, and what is the final answer? The final answer of out of the first three answers, minimum. So what is the first? What are the three? One is the strength governed by the yielding of a gross section. Second, strength governed by the rupture of a critical section. And third, strength governed by the block shear. So minimum of above three, that is comes to the 277.50 kilo Newton. So this is the way you can design or analyze, or you can say that you can calculate the tensile load capacity of the member. Okay, thank you.